Hello, I'm Stephen Rakusik with South Dakota Public Broadcasting.
I'm Del Droege, Professor of Biology at Dakota State University.
Today we're going to dissect the sheep heart, Dale?
Yep. We're going to look at an example of the mammal heart, and sheep are a good example of that. You also can order beef hearts, various other kinds of, pig hearts probably under certain circumstances. But I would say beef and sheep are probably the two most common.
Should we go ahead and get started?
Yeah, which one do we want to cut open? That one?
Try that one first maybe?
All right. So let's, like I say, I think in this case, again, I take a little bit of this aorta off just because it'll be kind of clumsy, and maybe just a little bit of fat off of here so that we can see what we're
as far as like
doing.
Cutting away, anything really to watch for as far
as up here around these blood vessels, I guess you do want to be a little careful. You don't want to cut too much, through some of these blood vessels that you would puncture into two or more.
We also meant to have gloves and probably plenty of soap around.
Oh yeah, they're greasy. The fat is greasy, and you can kind of see the shine on our gloves.
So maybe check it, as far as cutting a bunch of that, it might actually end up causing more.
Yeah, I don't think you want to get too carried away here. I'm just cutting a little fatty where we can see these vessels a little bit. And you can see there I'm cutting. You can see there I'm kind of cutting into a vessel already. That's one of them.
So where do you start then, as far as the actual cuts?
I say usually we try to follow the flow of blood into the heart, and so we usually traditionally think about the deoxygenated blood is coming back in the veins. Veins return to the heart, and it's entering the right atrium, which is right here. And you can see it's this one's a little on the back. So it goes from the right atrium to the right ventricle through the pulmonary artery to the lungs back to the left atrium, left ventricle, out the aorta to the body. So we'll follow that course.
Can be a little confusing. So maybe that extra PowerPoint we have
I would
with the video.
I think it'd be great to review that so that you really kind of the path of circulation of blood through the heart. I think that'll really help you understand what you're looking at. Anyway, so as that comes in then, so the blood comes in through the blood vessels to the right atrium. So usually you go ahead and open that right atrium up. And it's not going to look like very much. The atria are really just little sacs that receive the blood. So, see, maybe, I don't know, let's see if you can maybe, well, it isn't quite all the way through. Don't want to cut too deep, but there, see if you can open the, see when that'll open up. So,
this one's a little stubborn here. I don't know if we should go with a little bigger one. Maybe. That one's like, it's almost like it's up against there.
Yeah,
maybe we'll try this one here just to get the, well, it might be.
That one we've already cut through.
Try that one there once, maybe?
Yeah, okay. So again, the side here, the left side's thicker, right? And so this is the right atrium here. Cut a little bit of that aorta off.
And you run into this. Some might not be as nice as others.
Yeah,
no. They're kind of squished maybe, and
at different times.
That atria just seemed awful small, didn't it, Dale?
Yeah, it did. And so this is the right atrium on this one. Again, we just would cut it open and just spread that out. You can see it's just a hard for me. Maybe you can hold that better.
Yep, I'll hold there. You can open.
It's just good things are. It is just a sac, really. So the blood comes in, and you can see, for the probe, the blood will now go down into the right ventricle.
I think once they make that next cut, it'll actually be easier to see that atria.
So this is, this will be on your left. It's the organism's right, so it'll be on your left as it fronts towards you, and you want to cut down the side. And so take the scissors, and you'll be able to feel that there's a cavity behind there. That's the ventricle itself. And just cut.
Can you really hurt a lot here going?
Well, you could be a little bit, but as long as you're not too crazed about it. And so now as we pull that apart, you can see now we're into the.
You can probably see the atrium now easier too, probably.
Yeah. Now see, here's the atrium up here, and now this is the ventricle. And you see, I did cut down into the middle here a little bit, the interventricle, but so this is the atrium, and the blood goes down into this larger space, the ventricle. They don't look like big round chambers, so you don't want to get, sometimes you want to think what they look like in diagrams. They don't always look like that. They're going to be closed, and the blood would fill that up.
So what prevents the blood from going back then?
Yeah, great question, because see, the blood comes in here to the atrium, and then as the atrium contracts, squeezes like that pushes the blood down here into the right ventricle. And it goes through this flap, which are called the valves. And this is the tricuspid valve because it actually has 3 flaps. You can't see all 3 flaps in this dissection. And you can kind of get an idea here. The blood pushes through that. So the door, pushes through as it goes down, and then these chordae tendineae that are attached to these papillary muscles here, they prevent.
We've been all the way open
yeah,
there.
they prevent the backflow. So now when the ventricle contracts and squeezes, blood goes back, but those valves are going to push shut and prevent blood from going back into the atrium. So that's a very important. You want to recognize here the right atrium, the right ventricle, and then the tricuspid valve, which are these little flaps connected by these chordae tendineae, these strings-like structures that keep the valve from going too far back and stop the opening, stop up the atrium, so blood flows out of the right ventricle up through to the lungs, through the pulmonary artery, which would be over on, be a little harder to find, but over on this side.
Usually probably, the best way is probably a probe.
Yeah, probe into that. It's going to be a little
up behind
tricky.
the cuspid and just.
Yeah, and just push your way.
They're very slippery.
Yeah, push your way in there. And I don't think we'll cut into there because it'll ruin our left side.
Maybe cut the left side, show that one later maybe?
Yeah, we could maybe find that. So it'll be and it's the pulmonary artery that carries away from the blood. Actually, we can kind of go the reverse way this way. I think
there we
can
go.
maybe get it.
There it is.
Yeah, yeah, you can get it down, and there we go.
I can hold it there for you here.
Yeah,
so this would be, I'll open this up and you can.
Yeah, so you can see there's where the blood comes down through that opening, and that would, when the ventricle contracts, it'd go up, follow where that probe is. Maybe go all the way over here, Steve, and see then it comes out, and that's the pulmonary artery which leads out to the lungs. And of course that blood with no oxygen in it goes out to the lungs. It'll get oxygen and come back now to the left side of the heart.
I'll kind of rock it back and forth there so we can see that. So let's kind of go slow here.
Yeah, so
this
kind
could
of
cut that, but it probably end up ruining a lot of structures though.
Yeah, and there's a lot of blood vessels up there, so you got to kind of be careful about what you're doing, probe around a little bit.
Maybe one at the end, maybe a student could cut, if you're all done, because it will mess up the other side there.
Yeah, so I think we can probably take that out.
So that kind of describes the right side going to the lungs. Now what?
Right, yeah, and really it's best to think of the vertebrate heart, particularly the four-chambered heart of birds and mammals, as two pumps. It's got the right side of the heart is one pump. It brings in the blood and then pumps it to the lungs, and then the blood comes back from the lungs, and the left side of the heart pumps blood out to the body. So really, even though the heart is one structure, they are very separated. The right half has one function, the left half has another. Or at least, maybe they both pump, but they pump to different places. So it's a two-part pump.
So
all right.
Try the left side now?
Yeah. So here, I'll cut it and then have you hold it. So here's the left atrium. Again, the atria don't look like much. You might be kind of a hard thing for you to think about. They just look like this little flap of tissue. They're a little different color though, sitting up here on the surface.
Almost like broccoli or cauliflower.
Or an ear, like an ear, like they say. And so then you just cut that open, and you can see that then that's a little, and it's a sac that will expand.
Kind of pull it open there for you.
Yeah, so it'll expand when the blood is in it, returning from the lung. Okay. And then in the same way, we just go down. I'll go cut down the left side of and again, the body, the wall's going to be thicker here. So you might take a couple of cuts as you go through that.
Anything
thick
the person
muscle.
can really damage here, really?
Not again. I think you could probably hit some of those, chordaes and things, but I don't think you could do too much damage.
I think I'd be surprised at how much thicker this actually is, too. This is amazing.
Yeah, so let's open it. There you go.
Okay, I'll open this up for you.
Open him up, and I'll point to some things. So there again, the smoother walled tissue up here is the atrium. So that's the left atrium. And then here's this left ventricle, this spacing. Yeah, see how you got this big, thick muscle here.
I'll just do a quick comparison here. I'll just flip this over.
Yeah, flip it to the right side. You can see. Yeah, so there's the thickness of the wall, barely a quarter of an inch maybe. And here it's more like an inch. Much thicker. Once again, we have a valve. This one's called the bicuspid valve. It just has two flaps. And you can see those flaps here and here. And again, connected by these cords that prevent them from, you can see it prevents it from going too far back. So when the ventricle contracts, the blood pushes against that, and this prevents backflow into the left atrium.
It's also called a mitral, too. It's like mitral, bicuspid
I believe,
mitral?
yeah.
I hear people having that replaced.
Yeah, and their valves are one thing that do wear out, and people need to replace them, and they can do that type of surgery, which is amazing.
How about the flow from here now? It's
Okay. Yeah. Now the blood. So the returning oxygenated blood to the left atrium into the left ventricle. When that powerful left ventricle contracts, it goes up through the aorta.
probably the best way would be the probe
And
again.
again, I'd probe, and you can see that probe coming out, hopefully, into this. Yeah. Actually, we need to cut this off again a little here, I think. And shorten that aorta up a little bit, and that probe, yep, there it goes. Right out through there. So the blood, again, going, yeah, you want to hold that for me? And so the blood coming out of the ventricle, and then because the valve's closed, it can't go up into the atrium, and so it forces it up through this aorta. And so the blood can probably go all the way through, the blood comes up.
Should we cut one of these just to
Yeah.
kind of show there's a couple other valves? on
Yeah,
this?
and that's kind of cool. Yeah, another thing, you got to
You know,
prevent the blood from
bicuspid.
coming back. So awkward to hold this here so anybody can see what we're doing, but if you cut up into that aorta, I don't know if that's going to
Throw a
work.
probe in there maybe? Let me see if the.
I think we got it right there. Yeah, just got to push that back. Oh, here they are. They're over here.
Which one right here? I see it right there. I can hold it back
Yeah.
open for you. There's a couple
Yeah.
of them right.
Yeah, there we go. So here's
there.
so these are these little flaps here that Steve's talking about. These are also valves. These are the semilunar valves because they look kind of like a crescent moon. And so they kind of flap back. And these now prevent blood from, when the ventricle, after the ventricle contracts, it pushes blood this way. Then when the ventricle relaxes, you don't want the blood coming back. And so these act like little pockets. They shut and prevent the blood from backing up into the heart. So they push it out, and then these valves prevent backflow. So they're so-called semilunar valves. You might show it a little bit better in that one we had.
Yeah, this one right here, I think. Let me open this one up here. I kind of open up all this for you here.
Yeah, right here. Well, say that. Here's a semilunar valve here. So this is the aorta, and here's the semilunar valve right there. Both cases I cut a little deep there, but I think it'll be okay.
Yeah.
So this would be the left ventricle down here.
Yeah, if I show it right here, yeah, I can see it really nice.
Yeah, there's the semilunar valve. So, you know, not a terribly complex structure, but a pretty amazing one. It has, it has these strong pumping ventricles, and it has the valves and things to prevent backflow, and it beats 60 to 100 times a minute, every minute of your life. So it's an amazing structure, the way it keeps power going, and of course it's absolutely necessary for the circulation of blood through our bodies to bring oxygen and nutrients to our cells.
I would definitely suggest for this one to have the PowerPoints and photos.
Yeah.
I don't know, overheading up on the screen.
There's something about a heart, I think, like I say, there's just something about it.
Orientation's tough.
Orientation's difficult, and our conceptions, again, I think we kind of have these preconceptions of what a heart's going to look like. It's going to have these big chambers and all that, and mostly it's big, strong muscle. It's mostly what it is. So I think, it's certainly worth a little preparation to help you understand what it's going to look like.
Absolutely. Well, thank you so much, Dale.
Well, you're welcome. I think, it's a great structure, and hopefully everyone will learn a lot by doing it.